Welcome! In this series of short videos, we will look at topics for the PowerBasic Windows compiler. Today we will look again at the use of OpenGL, that's the Open Graphics Library, within your applications to do some molecular modelling. This was our application at the end of the last video. We have created a rotating view of a cube filled with a number of different coloured spheres. Having looked again at this, I noticed that some of the spheres were overlapping, and it reminded me of a molecular modelling application. So I thought, why not take this concept a little further and amend the application to display a number of different simple molecules. So let's go and have a look at the code. So in order to support this new molecular modeler, we'll need to make some changes to the code. The first thing I want to do is to set some constants at the beginning of the application. I intend to model just 3 molecules. I want the application to be generic enough to allow this to be expanded. The molecules we're going to be modelling are first of all benzene, secondly trichlorophenol, and finally caffeine. So let's create some constants for those molecules. So here we have our constants. One for benzene, one for trichlorophenol, and one for caffeine. And we're going to create another constant which will be set to the one we wish to actually model. So we'll start off with the simplest of these, which is benzene. In this new version, we're not going to be creating a box. We're just going to create the molecule itself. So there's a couple of new global variables I want to add to our list. And this is one to allow us to set the angle at which the atom will actually attach to the molecule. And the second one we're going to use for a bond count, counting the number of bonds in our molecule. So as these molecules have a number of different types of bonds, I'm going to create some global variables to allow us to track these bond lengths. And there we have our new global values. One for carbon to carbon, one for carbon to hydrogen, one for carbon to oxygen, and so on. So rather than hard-code the values as we have at the moment for the size of the spheres, we'll want to set the radius of each of the different types of atoms. So we're going to create some more globals. And we're going to set some of the values of these globals in an initialize physical constants subroutine. And here are our globals for the radius of atoms. And we're going to set one in here for the angle, which is going to be used to splay out the hydrogen atoms in a methyl group. And we have some more additional variables which we'll need for the caffeine molecule, which is going to be the most complex molecule we'll be modelling today. And here is our routine to handle setting up the physical constants for bond length, for atom radius, and also for our angles. So we're going to be calling this new subroutine in our winMain function. This will allow us to set these values up right at the very beginning of the application. And we will relabel the title of our window to PowerBasic OpenGL Molecular Modeler. And that's the only change we'll need to make to the winMain function. We'll still use the same message pump as we did before. And in the event handler, where we initialize the sphere data, we're going to replace this subroutine with another one, and its task will be to initialize our molecule. So as we're not going to be needing this old subroutine, we'll take this one out completely. So we'll comment this one out. So here is our new routine to initialize our molecule. It will test the module selected and will call one of 3 separate subroutines. One for benzene, one for trichlorophenol, and one for caffeine. So here is the new routine to initialize the benzene molecule. In this one, we've taken what were constants in the previous application and we're embedding these in this function to set the number of carbon atoms in the benzene ring, the number of hydrogen atoms, and the total number of atoms. And then, as we did before, we're using our arrays. These are all global to set the X, Y, and Z coordinates, the radius of the atom, and the colour in RGB. And then for each atom, we're stepping through and populating these global arrays. The idea being that once these global arrays have been populated, we can use the same render scene function to render any molecule. So there is one change I want to make to the render scene subroutine. As we're going to be dealing with slightly larger molecules, we may need to actually change our zoom factor. So we're going to change that to 12. And whereas before we used these arrays, we're going to be changing this to be using our global ones. And the number of spheres is now going to be a global variable for the number of atoms, depending on which molecule we're actually displaying. So there are our new global arrays. This should allow us to display any molecule we wish. And we're no longer going to be drawing the box, so we can comment out this function. And the draw box edges one as well. A quick compile to make sure we haven't missed anything. And if we try running the application now. And there is our benzene ring. The carbon atoms are shown as the large grey spheres, and the hydrogen shown as white spheres. So this gives us a nice, smooth, animated display, and it's working quite well. So having displayed a benzene ring, can we now display the trichlorophenol? Trichlorophenol is quite a common antiseptic when diluted in the UK. So let's go down and change our molecule selected to be trichlorophenol. And if we look at the initialized molecule, this is the subroutine we're going to be calling. This one is slightly more complex as there is more in here. We're still dimensioning the same arrays as we did before based on the number of atoms in this case, which is 13. So we have our carbon atoms. We have these in a benzene type ring. And we have a hydroxyl group here. So we have some oxygen atoms and hydrogen and chlorine. So this approach allows us to take a step-by-step construction of our molecule. So if we try running the application now, there is trichlorophenol. The chlorine atoms can be seen in the large green spheres. We have our benzene ring in the middle. We have our hydroxy at the side here showing oxygen and hydrogen, and 2 single hydrogen atoms here. So using this one application, we've now managed to draw 2 completely separate molecules. Of course, this arrangement of atoms is not absolutely perfect, but it's close enough to give us an idea of what the molecule will more or less look like. So let's see if we can manage caffeine now. So we've now changed our molecule selected to be caffeine. And here is the routine to initialize our caffeine molecule. Again, it takes the same approach by building up the molecule atom by atom. As this particular molecule is slightly more complex, with a total of 24 atoms and 25 bonds, this is obviously going to be more complex. However, we're still using the same arrays to populate, to define the structure of the molecule. And we're working again around another carbon ring. But this time we do have nitrogen as part of the molecule. And once these arrays have been fully populated and the angles set, we should be able to draw our molecule on screen. I'm not going to go through the code line by line, as it's fairly obvious what it's actually attempting to do. There's just a fair amount of code. So if we try running our application now, there we have our caffeine molecule. The nitrogen is shown in the blue colour, oxygen again in red, carbon in grey, and hydrogen as the white spheres. So now you all know what caffeine actually looks like. You can, of course, add a number of other more complex molecules to the list that this application can display. But as you can see, with a few basic arrays, you can go ahead and create a molecular modeler, albeit a simple one. Hopefully you'll find these techniques and this code useful in your applications, but that's it for today. Thank you for watching.
Thank you for watching today's video. Please feel free to click on the link in the description below to discover more videos.